Hi. Okay. Sorry. First time I'm doing this with my new document camera. Okay, so the question I'm seeing is you want to find the largest possible error if you use the fifth degree Maclaurin polynomial for sine x in the interval x goes from negative zero point 0.3 to zero point 0.3. I could see why this question is a little bit confusing because the answer I got initially is not the one they had listed. And let me explain why. Um, So I want to share my screen with you here. Okay, 1 second. Okay, so first of all, for the fifth degree Maclaurin polynomial for sine x, you can either derive the formula, um, but this is probably one of the four: sine x, cosine x, e to the x, and 1 over 1 minus x that you really need to have memorized. So sine x, you get x minus x cubed over 3 factorial plus x to the fifth over 5 factorial. Okay, so what I had originally thought, okay, the largest, to get the largest possible error, you look at this and say, oh, that's an alternating series. Okay, that's nice. If you look at 0.3 minus 0.3 cubed over 3 factorial plus 0.3 to the fifth over 5 factorial, you notice this is an alternating series. The terms are decreasing in absolute value and going to 0. That means you can use the alternating series error estimate, which says that the absolute value of the error is going to be less than the absolute value of the next term. So the next term is going to be 0.3 to the 7th power over 7 factorial. And the absolute value of the error has to be less than that. So that's the original answer I was going for. Then I looked and said, oh, wait a minute, this is not in your answers. So I thought, okay, well, what do we do now? So next thing to look at, which is more complicated, is the Lagrange error estimate. Lagrange error estimate. So this one says the absolute value of the error, and just to keep it simple, it's going to be basically less than the absolute value of the maximum possible value of the next derivative for values of x between negative 0.3 and 0.3 divided by, you just go up 1. So that'd be 6 factorial times the largest value of x we have between negative 0.3 and 0.3, which is 0.3. But I'll just get that to a minute. So this is the basic format. So the way they would probably want you to do this, if you look at the sine function and look at its derivatives, you know what the derivative is going to be, either a sine or a cosine, plus or a minus. So here's sine, here's the first derivative, you get cosine. The second derivative, you get negative sine. Third derivative, you get negative cosine. Fourth derivative, you get sine. Fifth derivative is cosine. Sixth derivative is negative sine. Okay. Now, the quick way to do it, the largest possible value actually for any of these is going to be 1 in absolute value. So this is going to be less than or equal to 1 over 6 factorial times the largest possible value this can be, which is 0.3 to the 6th power. So that's how they get their answer. But actually, to be more precise, what you could say is If you look at the sixth derivative here, notice that sine function, sine is in absolute value. This should be an increasing function from say 0 to 0.3. So the largest that this could possibly be would actually be the absolute value of sine of 0.3, and that would be over 6 factorial times 0.3 to the sixth power. Okay, but the sine of 0.3 is less than 1. So this is less accurate. This is more accurate. But if they're saying the error has to be less than something, you're safe on going with this expression here. So that's the answer they picked. I'm just surprised that they didn't go with the alternating series estimate here. And I want to unshare my screen now. Stop sharing so you can see my face again. Whole video, and there we have it. Okay. If you have any questions about how would you derive the Maclaurin series or anything like that, just let me know.